Hey guys, so I just wanted to give you a quick review on radicals. They are, by the way, square roots, okay? And so this is my little radical dude. Do you see, right? Radical dude. But there are two types of radicals that you're going to see that you're going to need to simplify, okay? There's some that are going to just be straight simplifying. And so the square root of 98, as soon as you type that into the calculator, you're going to get an estimated answer. So 9.89 is what the square root of 98 is, but this is an estimated answer. And so we can simplify this radical and keep it as an exact answer, and that's what the goal is. We're also going to do and review what's called rationalizing the denominator. And so what the idea is behind this one is that you cannot have a radical in the denominator, nor can you have a fraction underneath your radical sign, okay? All right, so let's go ahead and I'll show you how it works to simplify, okay? So let's start with the square root of 98. So one of the things that you have to do, or can do, is you have to kind of think, right? What is a perfect square that goes into 98? Remember, perfect squares are 4, 9, 16, 25, 36, and so on and so forth, right? And so if you can remember what goes into 98, then that is great. If you can remember which one of these. So one of the numbers, or one of the perfect squares that goes into it is 49. And so 98 is the same thing as 49 times 2. And then I can pull this apart. And so it's the square root of 49 times the square root of 2. And you know that the square root of 49 is 7. So this becomes 7 root 2. So the square root of 98, the exact answer is 7 root 2. Now, if I type that into my calculator and I just type in 7 root 2, look, I get the same estimated decimal answer, okay? So that's one way that you can check to make sure that you are correct. Now, if you don't remember, right, and you're like, right, I'm stuck and I don't remember how it works, then you can always do a different method. You can break it down using a factor tree, okay? So even if you start to do the factor tree and you're like, oh, check it out, right? Here I am, okay? And so the square root of 98 becomes 2 times 7 times 7. Well, 7 times 7 is 49, and the square root of 49 is 7, okay? So it just depends on what method you like better. Let's go ahead and do that one more time. So let's do the square root of 150. Now, I don't know about you, but sometimes my brain doesn't always work. And so I don't know what perfect square goes into 150, and I don't feel like typing it into my calculator to go figure it out. But I can do this factor tree relatively quickly. So I'm going to go ahead and break it down. 15 is 3 times 5. 10 is 2 times 5. So when I go back under my radical sign, I'm just going to put my 5's together. Okay, so 5 times 5, and then 3 times 2. So 5 times 5 is 25. The square root of 25 becomes 5, and then I get the square root of 6. All right, let's talk rationalizing the denominator. So again, you are not allowed to have a root in the denominator, okay? It's not allowed to be there, and I'll show you the method to that madness when we get into polynomials a little bit more. So what you have to do with 1 over the square root of 7 is you have to do what's called rationalize the denominator. Right now, the square root of 7 is an irrational number. So what I'm going to do is I'm going to multiply the square root of 7 by the square root of 7, because the square root of 7 times the square root of 7 is going to give me a square root of 49, which is 7. Okay, this is kind of the idea that's behind it. The problem is that you can't just multiply by a number without changing the value. The only number that you're allowed to multiply by without changing the value is 1. And so you are going to multiply by root 7 divided by root 7. Because remember, anything divided by itself is equal to 1. So you're allowed to multiply by 1. Okay, so that's what I'm going to do. So when I multiply the numerators, 1 times the square root of 7 becomes root 7, and then root 7 times root 7 becomes the square root of 49, which is 7. Okay, so 1 over root 7 is the same thing as square root of 7 over 7. And again, you can use your calculator to check your answer. So here's 1 divided by root 7. And then if I did root 7, I got to get out of my radical sign, divided by 7, take a look. I get the same estimated decimal, okay? All right, let's do that again. So let's do root 4/3, or the square root of 4/3, okay? So when you have a fraction like this, you want to pull it apart. You're going to do the square root of the numerator and the square root of the denominator. Now the nice thing is I know what the square root of 4 is, right? This is a 2. The bad thing is I now have this root 3 in the denominator, so I'm going to have to rationalize it all over again. So I have 2 over root 3. Again, I'm going to multiply by 1, which is root 3 over root 3. And then I'm just going to multiply my numerators and my denominators. 2 times the square root of 3 becomes 2 root 3. And root 3 times root 3 becomes the square root of 9, which is 3. The last thing that you want to make sure that you do is just double check to make sure that that 2/3 can't reduce. Okay, so if I check that answer, the square root of 4/3, here's that decimal, and then if I do 2 root 3 divided by 3, check that out, I get that same estimated decimal answer. Okay, let me know if you guys have any questions about these.